What if Alan Turing never faced prosecution? What if, instead of tragedy, Britain recognized its greatest mind and gave him a knighthood in 1954? In our timeline, the father of computer science was destroyed by the country he saved. But in this alternate history, Sir Alan Turing lives, and he is about to reshape the entire 20th century. This is the story of how one man's survival launches the personal computer revolution 30 years early and changes everything. In our timeline, the transistor was invented at Bell Labs in 1947, but it took over a decade for transistors to replace vacuum tubes in computers. In this timeline, Turing's knighthood gives him political protection and credibility. He uses both to bypass the slow-moving British government and secure private funding from industrialists who see the commercial potential of computation. By 1956, his Manchester laboratory has built the first fully transistorized computer, 2 years ahead of our timeline. But Turing is not interested in building a bigger machine. He wants to build a smarter one. While IBM and other American firms race to build room-sized mainframes for corporations and governments, Turing takes a radically different approach. He publishes a paper called On the Architecture of Universal Cognition in 1958, proposing that computation should model human reasoning, not just crunch numbers. His design calls for a machine that can process natural language, recognize patterns, and learn from its mistakes. He calls it the large logic model. Critics dismiss it as science fiction. Turing ignores them and starts building. In 1961, Turing unveils the hub. It is the size of a large television set. It sits on a desk. It responds to commands typed in plain English. Nothing like it has ever existed. The Manchester Protocol, as Turing calls his natural language interface, translates human sentences into machine operations. You do not need to know binary. You do not need to be an engineer. You type a question and the hub answers. The press calls it the personal oracle. Within a year, universities across Britain are placing orders. By 1963, the first hubs reach American shores. Turing sees something that no one else does. A single hub is useful, but hubs that talk to each other are revolutionary. In 1965, he connects 12 hubs across British universities using dedicated telephone lines. He calls it the distributed brain. Each hub shares its knowledge with every other hub. A question asked in Manchester can draw on data stored in Cambridge, Edinburgh, and London simultaneously. It is not the internet. It is something stranger. It is the first peer-to-peer network, and it is designed not just to store information, but to reason about it. The Cold War is at its peak. In our timeline, governments control information absolutely. State media on both sides broadcasts propaganda with no mechanism for verification. But the distributed brain changes everything. By 1966, nodes in West Berlin and neutral countries begin receiving and cross-referencing news from both sides of the Iron Curtain. Turing's early language models can compare claims, flag contradictions, and generate summary reports in plain English. Diplomats begin trusting the brain's analysis more than their own intelligence agencies. For the first time, a machine is fact-checking the most powerful governments on Earth. In our timeline, the Cuban Missile Crisis of 1962 brought the world to the brink of nuclear annihilation. In this timeline, it unfolds differently. The distributed brain's predictive models run thousands of simulations of nuclear exchange scenarios. The results are horrifying and unambiguous. Full nuclear war produces a 98% probability of civilizational collapse within 5 years. Turing personally presents these findings to both the American and Soviet ambassadors in London. The data is so overwhelming, so impossible to dismiss, that both sides agree to direct negotiations. The missiles are removed quietly. The crisis that nearly ended our world simply never escalates. By 1968, Turing's large logic models are sophisticated enough to generate original text, compose music, and solve scientific problems. But Turing sees the danger before anyone else. He publishes The Learning Limit, a landmark paper that addresses what we now call the alignment problem. His solution is elegant. Every logic model must be grounded in what he calls the imitation game ethics, a framework where the machine's outputs are constantly measured against human values. If a model generates a response that a panel of diverse humans would find harmful, the model corrects itself. It is not perfect, but it works well enough to prevent the worst outcomes. The 1960s counterculture movement discovers the hub. Musicians use logic models to co-compose experimental albums. Poets feed their work into the system and receive variations that blend human creativity with machine pattern recognition. Andy Warhol commissions a logic model portrait series. The Beatles use a hub to generate harmonies for their 1968 album. The technology is no longer just for scientists and diplomats. It belongs to everyone. Young people see the hub not as a cold machine, but as a creative partner, a tool for expanding human consciousness without the risks of the era's more dangerous experiments. Turing's final great project begins in 1969. Working with the city of Manchester, he deploys a network of logic models to manage urban infrastructure. Traffic lights respond to real-time flow data. Power grids optimize energy distribution based on weather predictions and usage patterns. Waste collection routes adjust automatically. The key difference from our modern smart cities is privacy. Turing insists that the system track patterns, not people. No cameras, no personal data collection, no surveillance. The logic models work with aggregate statistics only. Manchester becomes the model for cities worldwide. By 1972, Tokyo, Stockholm, and Toronto have adopted the Manchester system. In our timeline, we are still debating when artificial general intelligence will arrive. In this timeline, it arrives in 1987. The transition from large logic models to true AGI happens gradually, guided every step of the way by Turing's ethical framework. The machines do not suddenly become conscious, they become capable. They can reason across any domain, learn any skill, and communicate as fluently as any human. But because Turing solved alignment first, the transition is managed. There is no arms race, no data monopolies, no tech billionaires hoarding the technology. AGI is developed as a public utility, like electricity or running water. July 20, 1969. Neil Armstrong steps onto the lunar surface, just as he did in our timeline, but in his hand is something that does not exist in our history. A handheld Turing hub, no larger than a hardcover book, performs real-time navigation calculations, analyzes soil samples, and communicates results back to Houston in plain English. Back on Earth, a 77-year-old Alan Turing watches the broadcast from his home in Manchester. The machine he imagined in a university office 15 years earlier is now standing on the moon. The logic he birthed has reached the final frontier. Looking back from May 2026, the gap between Turing's timeline and ours is staggering. In his world, the singularity happened nearly 40 years ago. Climate change was solved in the 1990s using AGI-optimized energy systems. Disease was mapped and conquered by machines that could simulate molecular interactions billions of times faster than human researchers. In our world, we are still arguing about whether AI will help us or destroy us. We are 50 years behind a timeline where one man lived instead of died. In our timeline, Alan Turing received a royal pardon in 2013, 59 years after his death, a pardon for the crime of existing. In this alternate timeline, he received a knighthood instead and used it to build a future we can barely imagine. The distance between those two outcomes, between a pardon and a knighthood, between punishment and recognition, is the distance between our world and a better one. Sometimes the most important technology is not a machine. It is the decision to let a brilliant mind live and work in peace. If this made you think, subscribe. The next Divergent Past is already loading.